So we're in Visual Studio 2008 now, and we are going to create the program for the Windows CE ZNAV device that is displaying the RPM we are getting from the instrument cluster. So we create a project, Smart Device Project, we call it display. Then we have to select Windows CE. The net framework version, I have no idea. I think my device is uses an old enough version to only use 2.0, but I use 3.5 anyways, and I haven't had a problem until now, so I think it's fine. Yes, and device application, and then we hit OK. So the first thing I wanted to do is to adjust the size of the program to the size of the display of the navigation device, just so, well, we don't want to see the Windows background when we're displaying our RPM. Also, I want this line on the top here disappeared, so control box false. Also, where is it? Oh, here. None is border style, and then we can change the size, and the size of the display of my navigation device is 800 times 480 pixels, so this is the sort of thing we can work with. So now we need a few things. We need a timer, we also need a serial port, and we are going to go through the code later, but for now we are going to make the design, I think, just because the design is more fun. So you're going to have a label, and this label is going to be fairly big. So we are changing the font also to, I think I like this one, and maybe 48. Well, it has to be bigger. So try 72 then. Yeah, I think that's fine. So we have to find a better font. I think I don't like that now. No, that's not good. Oh, wait a minute. This one looks fun. So we're using this, and I don't know if I should center the value, also make it bigger. Let's make it 100. And let's roughly center it for now. So this is the RPM value. Then we add another label saying RPM. And we are going to make this one a little bit bigger also. Just like that. Also, we are going to add the text align to the right, so it's always close to the RPM text here. So if we have 750 RPM, there isn't a gap here. So we have that for now. And now I actually want to add a kind of a progress bar to that. And I want to have 2 of them. And you're going to see later what I try to do with those. So that's about right. Also, I want to have a button right here in the middle. So this button doesn't have any text. It's also going to be getting another color. It's going to be transparent for now. So all this is going to be a progress bar that the higher the RPM goes, the more to the left goes each of these, and this is going to be a shift light that lights up shortly before red line. That obviously only makes sense if we actually can use the RPM signal in a way that it's updating fast enough. I'm not sure yet, so well, we go with it anyways. Sadly we can't add any other things right now because, well, we can't. We could make a average RPM value. So this basically will display the average RPM since the program is running, and maybe we can also make a maximum RPM since the program is running. For some reason it doesn't like it now. You have to make it transparent, I guess. Oh, that doesn't help for some reason. On this side it works fine. Well, I guess now it works. Weird. So I hope we can change the color of this progress bar. Also we have to reverse this one. Wait, doesn't that work? That's stupid. I'm pretty sure I used a reverse progress bar already, but I guess it wasn't a Windows CE device or a Visual Studio 2008 version. Stupid. Well, then we have to change this. Then we are going to have the shift light on that side and the progress bar right here. But I think we can even change the color of the progress bar, which would really suck because I don't really like that blue color in progress bar. So yeah, it kinda sucks. Is there anything else we could use for a progress bar? Well, we could use a bunch of buttons. I guess that's what we'll do. So So that's that for now, and now let's start writing a few functions. I don't think we add a serial port connect or anything or debug for now because it's just how it works. So when the form1 loads, we have to initialize the serial port. So So we could add the port and baud rate right here, but just in case I want to make it changeable later on, I'm doing it that way. So I think that is all we have to do on a form1 load. So now we have to enable the timer. Interval equals 500. So we make it 500 milliseconds of an interval to start with, and we have a acknowledge function later, and as soon as the device is connected to the Arduino, the acknowledge will run through and the interval will be lowered down to 10 milliseconds. And maybe we could even lower it more. I just don't want to have the Windows CE device crash. So now we are going to write a few functions we need for this whole thing. So first of all, we write a function that reads the serial data. So that's basically that. Then we also need a startup acknowledge function. type today. And as we're right here, we're also going to add a little button right down there in the edge that turns green if we are connected. And we're also going to add a text. Just in case. So So what these functions all do, so the read serial data function just reads the serial port, the read line, so read line always reads the full line, so we are not missing out on any data since we are also using the print line command on the Arduino. So each line we send will get received, and basically it just returns the serial data, so this is just so we don't have to have the serial port read line command everywhere. You can just serial read line, call serial read line, and the start acknowledge function is pretty self-explanatory as well. So we have the acknowledge value right here, and it's always false. Oh, we have to forget something. We have to return the acknowledge value, so it's always false, and we return false, and we read also the each line that comes in with serial read line. And if we get a string that contains A, which is pretty much a string that's only A, because I'm sending from my Arduino, as soon as the Arduino is powered up, I am sending A, one after another, and as soon as it reads A, the acknowledge is true, and the serial port writes a K, and the Arduino is going to receive the K, and by that the Arduino is going to know that the navigation device has acknowledged the Arduino and the other way around. So at this point the devices are connected. So we set the timer interval down to 10 milliseconds, we set the back color of our connected button, and we also set the text to connected, and at this point the timer will start to read the serial data, and that is what we are going to do next. But we are just going to do one little function before that, and this is a function to get the value and the type of the data from the data we received. This isn't needed if we only use one value, but if we want to send different values over the Arduino, we are going to need this. So this is the other function. And the received data will look like this, for example. So the R in front stands for RPM, and that is so we know that we are receiving a RPM value right now. Then the X is the divider, and the 3445 is the actual value. And right here, if we call the function, we are giving the received message over the function, and then we split it right here with data string split, a split function of string, and we split it at the X. So we are going to receive into that data array the part before the x and the part after the x. So data array 0 is R and data array 1 is the value, and basically we're splitting that, and we are going to use this right away in the timer function. So now we are doing the timer. So first of all we're doing the acknowledge function, and now we have to declare another variable. So so well, well, actually the other way around would be way more sensible. So that is because most of the time it is going to be acknowledged, so this the else wouldn't even be called. So this is just for performance reasons, but I know we're in Visual Basic and we're writing a Windows CE device, so performance is very questionable anyways. So as long as it isn't acknowledged, we are going to call the getStartedAcknowledge function, and basically that is all we need for the acknowledgement. And as soon as we have acknowledged, we are, oh wait a minute, no it's alright. So as soon as we have acknowledged, we have to read line. So now we are reading the message. Alright, I'm back. I had to pause for a second. It could be that this is now going into a second video because the first one is already quite long, but I'm not sure. Also, we are already almost finished, so maybe I put it all in one video. But now we have the timer is going to call this call every 10 words. Where have the words gone? So in case we have acknowledged, we receive the message as a string, and then we have to convert the message to type and value. So we do a type and value as string equals type and value. Something's wrong. 1 second. Right, I'm stupid. So we have to obviously type and value needs the received message to get us the type and value. So is type value 0. So if type and value 0, as you might remember, type and value, the 0 of the array is the type, and the 1 of the array is the RPM. So now we update the label. And also we are going to, oh, I'm stupid. Right. Also we have to do the average RPM right now, so oh, I'm always making the semicolons from the Arduino programming. So yeah, average RPM, and now the other functions and things I already had done once before, but the average RPM I haven't done yet, so it's pretty much going to be live on camera. I have to think about something. So, well, how do we do the average RPMs? So we have an average count. So every time we update the RPM text, we add average counter. And that is again, we add 1 to the counter, and also we add the, well, that might be a stupid thing. Well, I'm going to show what I thought we are going to do, but so yes, I was going to add all the RPM values up and simply divide them, but for example, if we drive half an hour and basically we get an update whatever 1,000 times a second or something. Now that's a little bit often. We have a timer interval of 10 milliseconds. That means that we have 100 frames per second roughly, so yeah, 100 updates per second. That makes 6,000 updates per minute, and on half an hour, that times 30, that I can't calculate in my head right now because I'm stupid. So 6 times 3 is 18, and we have 4 zeros, so we have 180,000 values. And now you're going to need a calculator, so 180,000 times, let's say we have an RPM value of 5,000. Yeah, makes a pretty long number, so this is the basic idea I had, but as you can see, after half an hour we already have a pretty long number, and if I'm driving for a few hours, that is a quite a big number, but maybe we can still do it like that for now and just see if it will make any problems. I mean, after all, we are not on the Arduino right now, we are on a Windows E device, and this should be able to compute large numbers, so yeah. We just might have a problem that the integer runs out, but we're going to see. So yeah, so the average m equals average m divided by average counter and label m. So we wouldn't need the average RPM that I can't even type. Oh, yeah. We wouldn't need the average RPM value, but just in case. So also we have the maximum RPM. And the maximum RPM is pretty easy. We are just going to do m equals max, and then max So basically oh, what did I do wrong? Type and value is in the integer. Type and value is a string, so mathmax can't call a string. Can I do something like to int? Well, I could try that, but I think that doesn't work either. No, obviously not. Well, I know you can use cstring, cstr, so I might that, for example. What's wrong now? Oh, one more. Yeah, I'm stupid. So I think that will work right like that. So it basically uses the maximum of both, the bigger of both values. So if our RPM value is bigger than the last maximum RPM, we are going to have a new maximum RPM. Otherwise, the maximum RPM stays the same. So this is pretty much all right here. We could use something to access the time date function of the Windows CE device to show the average RPM since when the average RPM is computed. We also could display a basic clock right here, but the problem with that is that the Windows CE device has a dead battery, and every time it's switched off, the date and time resets, so that doesn't work. Though, oh, I completely forgot, we have all those buttons I wanted to light up. So I guess we'll pause the video right now, and we are doing the buttons in a separate